cylinder H, some X length is immersed. So this is rho 1. Now, so let's calculate the buoyant force weight of the solid at equilibrium. Buoyant force equal to weight of solid equal to the net resultant force should be 0. So what is the buoyant force? Density of liquid rho 1, volume immersed V dash into G, weight of the solid. Or so what is the condition of this? Like how directly shall I write here? So what is the X length? X length immersed should be equal to density of liquid by density of solid into H. Okay, when you solve it, we'll end up this one. What is V dash? V dash should be equal to A into X. What is A? Area of cross section of cylinder. This is cylinder. Huh? Now what I'm going to do? I'm going to pour another liquid such that what happen? Some length will be immersed in first liquid, some length will be immersed in second liquid. Then what conditions will arise? Now what will happen to solid air? It all depends upon the density, all that one. I'm giving some rough diagram. Sir, why you are showing it will rise up? It all depends upon the so there's another liquid. So what is this question? When it comes as the interface of two liquids, some length is immersed in first liquid, other length is immersed in second liquid. Then how to deal with such numericals? Okay, this is second liquid. There's a very good problem. You check it, no, almost every book, this question is there. So rather than numerical, no, some concept is there. So I wanted to cover even that concept also. Just focus on the basic equations and also some concept. Say, I think this water is like a, suppose some wood is floating in a water. Then if you pour kerosene, will it mix with water or will it mix with wood? Nothing will happen. No? So then water and kerosene will not mix. Some part of wood what happen will be immersed in kerosene, some will be in the water. How to calculate what length is immersed in individual liquids? That's what we are trying to search an equation here. Yeah, fine. Okay, now this is the sigma s. Some x1 will call it, and let this be x2 length. The total H as it is, and it's the same cylinder, area of cross section A. Now the new buoyant force. How you do this problem? So let's do one thing. So let's not bother about the basics here. Let's not bother. So the liquid present here will exert a force. Will I agree? P2A. The liquid present here will exert a force. P1A, weight of the solid. I think this much anybody can. This one. So what is P2A? We don't know. Okay, let's calculate buoyant force here. So first it's in equilibrium. So at equilibrium, what you can write? P1A minus P2A. So what is P1? P1, what you can write it as? P2 plus rho 2 Gx2 plus rho 1 Gx1. From where this I brought it? Manometric equation. I want pressure at 0.1. Please, very important. Don't go here and there. Already we know enough of manometric equation writing. The pressure at this point is how much? P2. So I'll move down. Rho 2 Gx2. Rho 1 Gx1 minus P1 equal 0. So in place of P2, what we can write? Sorry, in place of P1, what we can write? P2 plus this equation. So substituting this, P2 plus rho 2 Gx2 plus rho 1 Gx1 into A minus P2A. So P2A and minus P2A, this will get cancelled out. So rho 2 Gx2 now what is weight of the solid? Weight of the solid should be density rho x, where that A should be there, no, here. Density of solid A H into G. So GA gets eliminated. So we'll end up with the equation rho 1 x1 is equal to rho s h. There's the equation 1. One more equation we can write it. What is that? X1 plus x2 must be equal to h from geometry. So let's solve this. There's equation 1. There's equation 2. Solving 1 and 2. Now from 1 and 2. I think I'll, yeah. Good. So let's, I'm interested in x1. What would happen to x1? So let me eliminate x2 here. So this will be rho 2, x2 we can write h minus x1. So this will be rho 1 minus rho 2 x1 is equal to sigma s minus rho 2 into h. Now look at x1. What will happen to x1? Will it be greater than x or less than x? Can we compare anything? Check calculation. I think I'm right. Rho 1 minus rho 2, no? Here, yeah. Rho 2, let me take common. So this will become okay. Now you can clearly tell it. What will happen to x1? X1 less than x or greater than x? Anything can be compared. I think I say rho 1 by sigma s is needed, no? Okay, no, yeah, fine. No, if I pour a liquid, so let's get into the thing, that one. If I pour a liquid, if rho 2 greater than rho 1, definitely rho 2 greater than rho 1, rho 2 greater than rho 1. Check once calculation. I think I'm right. This equation. Rho 1 minus rho 2 x1. I'll rewrite it in terms of rho 2, rho 1. So let me take rho 1 common here. Sigma is, keep as it is. And there's one very good equation. More theoretical questions are there. There's no way you should have this mathematics in hand you. I'll pour a liquid. So what is this liquid? I'll put a condition. The density of this liquid is greater than rho 1 and less than that of solid. What will happen to x1? I think you can put it here, no? If you want to send rho 1 inside here, this h should be here. No. If you want to send this rho 1, rho s by rho 1 h. Density of liquid. So sorry. Here it is wrong. Now get exact picture. Check with this condition. Very beautiful equation. I really, you do have this theoretical question. I don't know students like why they don't want to use maths here. They either they remember that condition or they just skip the question. But you are supposed to analyze here. What is X? Earlier the length of cylinder immersed in the first liquid. No, when you pour other liquid, what will happen to the length of solid in the first liquid? Will it increase or decrease? Who will determine? I think this equation. So you bring that rho s h here further. Let me go for sigma s h rho 1 minus all divided by this. I'll not disturb it. Let it be as it is. No. What is sigma s h by s will be x, no? Now you have in front of you, you have equation. Now analyze this and tell me. Will it increase or decrease? It depends upon rho 2 and rho 1, this equation. Nothing to do with denominator. Look at the numerator. This value. If rho 2 greater than rho 1 and the product and rho 2 by rho 1 by h, if it is less than x, the less than x will decrease here. So like this, what happens? It will increase or decrease, or how much it will increase, or will it rise up, or it will go further down. If you calculate x1, if x1 is greater than x, then what will happen? This cylinder will further go down into the liquid. If x1 is less than x, it will rise up. So it is given by this condition. Okay, I think if you have values now, you can readily check this. So there's a one very good equation is what I brought it. Very important, you have a numerical, like iron floating in a mercury. Now I'll pour kerosene. What will happen to length of cylinder immersed in the mercury? Will it increase or decrease? So that what you are going to pour, this is the kerosene. This is what rho 1 is iron. Fine. I'll go for next case here. What is x1? X1 is the new length. Like this, I have brought expression for x1. Can you bring expression for x2? Substitute this in the equation 2 or substitute here, solve for x2. What length is immersed in this liquid, you'll come to know. Now your task question, sir, where is the buoyancy? You didn't brought buoyancy. You can also write what is the buoyancy? Rho 1 ax1. I should write like this. Nothing wrong, no? No, few definitions. I wanted to clear it. So what is a buoyant force? Density of liquid, volume immersed in first liquid into G, density of second liquid, volume immersed in the second liquid into G. That's what it says. Now, what is the net force exerted by the upper liquid on the solid? Will be downward. So this is not buoyant force. This is not a buoyant force. P2A is not buoyant force. P1A minus P2A is what? Buoyant force. Able to get this? So directly you can write it, no problem. Able to make it P2A will not be buoyant force. P1A minus P2A, the resultant of the net force exerted by the liquid on the solid, which is directed vertically up, is what? The buoyant force. That the definition says. And that's what I am writing here. Same thing, one of the same. You solve P2 minus P2A minus P1A, you'll end up with the same equation. You can also solve like this here. Fine. Okay, now one last very important and essential one. I think what is the case? Case 7 will take it here.